All right, so let's keep going with our knowledge of trying to graph a parabola. On 9.1, we just placed a basic parabola. Today, we're going to move this parabola off of the y-axis, meaning we're going to do a little bit more work to actually find out where it's located. So, just a quick review. First, the position of our parabola is linked to this A, B, and C. So what we want to make sure we do is that we have everything written in standard form before we start. So remind ourselves that this is the standard form we're searching for. And we want to know what is A, what is B, what is C, because those values are going to determine where items are placed. Also, a bit of a reminder from 9.1. Our vertex is the highest or lowest point of the graph depending on the way it opens, and it sits right in the center. The dashed line that goes completely vertical through it is called our axis of symmetry. It is the line that we could fold the parabola on because the right and left sides would fold over and be identical. The x-intercepts are going to be important to us when we get to lesson 9.3, so we'll talk about those more. And then depending on where your graph is located, typically you will have a y-intercept. All right, so what's important to us when we graph these and we don't know where the vertex lies? So first off, when you initially look at an equation, you should be able to determine its orientation. So the orientation is whether it opens up and down, and eventually in Algebra 2, you're even going to get parabolas that open left and right. So if you have something in standard form, it is as simple as looking at the value of A, and determining if it is positive or if it is negative. If it's positive, it's going to open up. If it's negative, it's going to open down. One of the reasons why this is nice is sometimes if you get to an equation on like a standard assessment, it may just ask opens up or down, or you may have some type of matching, and you may be able to narrow down which equations go with which graphs just based on this orientation. So using it can be very important to you. And even though that is an important piece, I'm going to change the color of that so my color coding works. Technically, the starting point of these graphs is going to be determine the location of the vertex. Each graph has an infinite number of points. It makes sense for us to find the one that is smack dab in the center. And this is kind of the process when we start with an equation given to us in standard form. Now, you're going to notice that these two formulas are the exact same because of the fact that the axis of symmetry runs straight up and down through the middle of the vertex. Oopsie. Ooh, that's fancy. The only difference here is the vertex piece is going to give us a coordinate. So when we are searching for this point, our x coordinate will be found with this. And when we're looking for the axis of symmetry, it's going to give us an equation of a line. So this is actually the equation of a vertical line. And on your worksheet, I try to assist you in reminding you to write this as an equation and gave you some examples. So we will always write that as x equals and the value. Now, before we go back into the full-fledged process of creating our graph, what I would like to do is just practice these little pieces. So how do we determine orientation once we have a full 3 terms in our quadratic function here? And how do we determine what our axis of symmetry and vertex are? Then we're going to apply that skill again as we do the full graph. It doesn't hurt to list somewhere the values of A, B, and C. So now let's look at that here. So they are our coefficients. It is only the number, not the actual variable. A is always the number that sits in front of your x squared. So for this particular case, A is a -2. B always sits in front of x, so in this particular case, it is a 12. C, and even though it's not something as part of our formula, it's not a bad idea to practice recognizing which item is C. It is -7. So just based on knowing that our equation has a leading coefficient of -2, if we're asked if it opens up or down, we could state that the answer is down, since A equaled a negative number. All right, so now let's practice the fun part. It really doesn't matter which one you tackle first, but so axis symmetry or vertex, typically axis symmetry might be the simplest because it's just one number versus trying to find both of our vertex. Again, same formula, so let's go ahead and write that down. We have the opposite of B over 2A. So for this particular problem, we know that x is equal to the opposite of opposite of B, which is 12. So the opposite of that would be a -12. Divided by 2 times A, which in this particular case is a -2. Now, when things are in fractions, just be very careful you enter this in the calculator that it does the correct order of operations. It doesn't hurt to maybe just go ahead and take this to the next step and just say that's the same thing as -12 over -4, which means we have an axis of symmetry at x equals 3. And yes, you will write it as x equals 3 because it is an equation of a line. So if we were graphing this one, which we're not, we could draw our axis of symmetry vertically through the number 3 on the x-axis. All right, so in doing so, we actually also have the first part of our vertex since these numbers are shared. So this 3 is also the x-coordinate of our vertex. This is a glorious thing because we don't want to just be shooting in the dark trying to find the points that are in the middle. It can give us a formula that goes straight to it. And then all we need to do is then substitute in. So I'm going to take our original equation, y equals -2x squared plus 12x minus 7. And we're going to plug 3 in for all of the x's. So we're going to go -2 times 3 squared plus 12 times 3 minus 7. And you should be able to enter that straight in your calculator. If that value is negative, the parentheses for the squared are extremely important. And this should give you 11. So the vertex of this graph is at 311. All right. So now you have all the skills you should need to graph a parabola by hand. So let's practice it. And we're going to apply the steps that we started in 9.1. And then we're also going to add your favorite in. And we're going to discuss domain and range a little bit when we finish. So again, dealing with quadratics a lot is determined by what A, B, and C are. So if we go through and we look at our leading coefficient, our linear terms coefficient, and our constant term, A, B, and C for this particular graph, or for this particular quadratic, are 3, -6, and 2. Now yesterday on the 9.1, we went straight to the table of values. However, we have to know where to start our table of values. So before we can do that, we are going to use our formula to determine where the center of our graph is located. So remember, it's opposite of b over 2a. So we're going to say x equals the opposite of b, so the opposite of a negative 6 over 2 times 3. Two negatives make a positive, so we should get 6 divided by 6, which puts our axis of symmetry at x equals 1. So if we wanted to go ahead and plot that, we could. You go over to our graph here, and we could put a dashed line all the way down where x equals 1. And we know that this should split our graph in half. Oopsie. Try to get it straight. So there's our axis of symmetry. Again, finding that first is kind of nice because it already gives us half of our vertex. So we know that the x-coordinate of our vertex matches that. So this 1 goes here. And to find our y, we're going to plug 1 in for x and all of the x's in our equation. So we have 3 times 1 squared minus 6 times 1 plus 2. I believe when you plug that into the calculator or do it in your head, you should get this to be a negative 1. So we know that we have a vertex at 1, negative 1, which should land on our axis of symmetry, which it does. So there is the middle of our graph. And here is our vertex at 1, negative 1. Now you'll notice in your homework, it's broken into several pieces. Sometimes that's all you have to find is like we did in example 1. And sometimes you use this process to then go ahead and graph the whole time. All right, so now that we have that, we can fill in our table. So we know our vertex is at 1, negative 1. And we're going to adjust our domain accordingly because now we're no longer at 0. So since the center of our graph is at 1, if we go 2 to the right, that would be at 2 and 3. And if we go to 2 to the left, it should be at 0 and negative 1. And it's important that we adjust this so that we still have that symmetry between our points because of the fact that we know our parabola is symmetric. So if we take turns plugging these in, if we plug 0 and 2 in, we should get 2 as our y. And if we plug negative 1 and 3 in, we should get 11. So if we want to go ahead and plot those, so 0, 2 is here. And again, if we reflect it across, that hits at 1, 2. Sorry, at 2, 2. And then we have negative 1, 11, which is just 1 right above the top of this grid here. And we go 2 to the right of that, we should be at 3, 11. And then we have our graph. So I'm going to connect it with a smooth curve. Whoop. Goodness gracious. Let me try that again. 3rd time's a charm. There we go. Arrows at the end, and there's our graph. Now in the homework, I don't have you state domain and range, but I would like to discuss it so that we can be aware of how it relates. So remember, domain is our input. So we want to be very specific. The 5 numbers we chose were negative 1, 0, 1, 2, and 3. However, the question becomes, what numbers could we have placed there? And for a parabola, that answer is all real numbers. So remember, that's this symbol here. So the domain of this graph is all real numbers. The only reason it wouldn't be that is if we were to adjust this to fit a specific story problem, where a specific set of numbers would be what made sense. However, since this graph does hit a vertex and turns and goes back the other direction, it means that there is a section of the graph that is not part of the U shape. So, because of that, we're going to visit this lowest or highest point, which is here, and we're going to ask ourselves, what is the y value at this point, which in this particular case is -1. So this graph never goes below -1. So our y values are all located greater than -1. Now there are two parts here that shift every time you do this domain and range. First off, this here is based on the orientation. So since it opens up, that is a greater than symbol because the graph is above the point. If it opened down, we would use less than. Another item to take note of is the fact that this -1 should match the vertex. Since we know that the vertex sits at the highest or lowest point of your graph, it should make sense that its y-coordinate should match your range. All right, that's the process of graphing a parabola when we don't know exactly where its middle sits, but how we can discover it based on an equation written in standard form.